Hi there, intermediate algebra students, and welcome to another online lesson. Notice the cool chalkboard type look, retro. So this is 12.6, rational expressions with unlike denominators. So we'll start with a pretty easy example, one that you've done a year back. If we're trying to simplify this expression 3/4 minus 5/6, once again, of course, you remember that in order to put together any kind of fractions, adding or subtracting, you need common denominators. And so in this case, our common denominator, we look at the 4 and the 6. You can always multiply them together. So one common denominator might be 24, but we always like to try to find the least common denominator, the LCD, sometimes we call that. And so it looks like in this case it would be 12. So what I'm going to do then is I'll try to write this as something over 12 in each case. And so then I notice on my first one, 3/4, well, I'd have to multiply this by 3, that denominator by 3, and then I'd also have to multiply my numerator by 3, so I'd get 9/12. And down here, I multiply my denominator by 2, my numerator by 2, so I get that. Now I have my common denominator, so now 9/12 minus 10/12 is negative 1/12. So that's our rationale. Again, it's not anything done. But now, of course, it gets a little bit tougher when we get to variables in the denominator. Once again, what do you think your least common denominator might be in this case? Well, we have a y squared and a y to the third. You can't really go down in powers when we're looking for those common denominators. So I would say it's going to have to be y to the third as far as the variables go. And then if we look at the numbers, we have a 3 and a 12. Again, we could multiply those two together to get you 36. But looking for the smallest common denominator, I believe it would be 12 for the numbers. So I'll write that in there. And then what do I have to multiply this denominator right here by to get 12y to the third? Well, it looks like it would have to be a 4 and a y would give me that correct denominator down there. So I also multiply my numerator by the same thing. Remember, when you multiply by a fraction that has the same value in the numerator and the denominator, that's like multiplying by 1. Does not change the value of anything. That's what we want. So 4y times 2 then becomes 8y. Meanwhile, over here I didn't need to change anything, did I? So my final answer then becomes 12y to the third. That's my denominator, of course, since that's the same thing. And my numerator, the best I can do then is to write it like this, 8y minus 1. Can I do any reducing or canceling here? Well, I can't cancel those y's, once again, because they're added or subtracted. So this is my final answer. That's the best I can do. All right, here. All right, let's try this one right here. Now notice we get a little bit tougher yet even. What's my common denominator going to be here? Well, as usual, as we've seen these last few lessons, factoring is really a key thing. Hopefully you might recognize this r squared minus 16 as something that could be factored. And sure enough, it's one of those difference of squares. And you can actually factor it as r minus 4 times r plus 4. And that might help you see what the common denominator here is going to be. We already have an r plus 4 here. We have this broken down to minus 4 and plus 4. So I would bet that our common denominator in each case will be the whole thing, r minus 4 times r plus 4. So I'll write that out like this. Doesn't really matter the order that I write that out at. So what am I going to have to multiply by? Well, my first fraction I don't have to multiply by anything, do I? Because that denominator is the same. So that's just going to be plain old r right there. Meanwhile, though, my second fraction I'm going to have to multiply by something. In order to get this for a denominator, I already have the r plus 4. So now I'm going to have to multiply by r minus 4 over r minus 4. Again, that's like multiplying by 1 and so that works out okay. So noticing then my numerator becomes 5, and then I better make sure to put parentheses around that, r minus 4, like that. Now my final answer then will be maybe slightly tricky. Again, my denominator will stay the same, but when I add these together, notice on my second fraction I can actually distribute this a little bit, so I'll get 5r minus 20. So now when I add my numerators together, kind of highlight those, which ones we're adding together here now, r plus 5r minus 20. Well, r plus 5r, that's like 1r plus 5r, so that's going to give me 6r minus 20. That's the best I can do there. I'm going to leave my answer in factored form then, my denominator, r minus 4 times r plus 4. And that's my final answer then right there. Again, it looks a little bit strange, but that's the deal. We have common denominators, and we're able to combine that weird fraction looking thing. Alright, really just one more example on this little online lesson. Now this one looks like a bear, doesn't it? When we look at these two denominators, they don't look too much alike. There is an x in each case. Neither of them can be factored really, and so if that's the case, if neither of them can be factored, my whole denominator is just each of them multiplied by each other. So my common denominator will just be 2x minus 7 times 3x plus 1, like that. So that means then that I'll have to kind of think about this a bit. My first fraction, in order to get that for a denominator, I'm going to have to multiply by 3x plus 1 over 3x plus 1. And when I multiply 4 by each of those, you see that I can, I'll just write it all out for now, 4 and then times 3x plus 1, like that. Okay. Meanwhile, my second one here now, in order to get those common denominators, I'm going to have to multiply that fraction by the 2x minus 7 over the 2x minus 7. Again, multiplying by 1, which is perfectly legal. So then I have 5 times 2x minus 7. Now I can do a little bit more with my final answer here. I'll just simplify or distribute this a little bit. So on my numerator I have 12x plus 12 plus 10x minus 35. And I still have my same denominator then, of course, the 2x minus 7 times 3x plus 1. And I can simplify this a little bit. That's what I want to do ultimately here. I can put my x's together to give me 22x. And 12 minus 35, it looks like that's going to be minus 23. And all of that over my factored form of my denominator, 2x minus 7 times 3x plus 1. So it looks like kind of a mess, kind of intimidating with all those expressions there and everything, but again, the strategy is the same thing. We got to get common denominators. When we have these rational expressions, it's just a little bit more complicated. All right, thanks for watching, everybody, and we'll see you in class on Monday. Thanks now. Bye.